Section 11.6 Obtaining Gibbs energy of reaction and entropy of reaction from cell potentials. First, let's review entropy. dG equals negative S dt plus VdP. Write it down. When pressure is constant, VdP is 0. Cross it out. dG is equal to negative S dt. So entropy is negative dG over dt under constant pressure condition. So entropy, again, it's negative delta G over delta T under constant pressure condition. What about the change of entropy of a reaction? You simply apply this equation for the products and for the reactants separately, and then take the difference. That's the entropy of the reaction, and if you do so on the right hand side, it's negative delta Gibbs energy of reaction over delta T. Alright? And then this is the nearest equation. Make sure you measure the C in a reversible process. Just make sure your electric current is infinitesimal. It approaches 0. So maybe you need to use a counter voltage to cancel most of the voltage generated by your electrochemical cell. Alright? And then if you do that carefully, you get this electro potential in a reversible process. Plug it in, you get the Gibbs energy of the reaction. And remember, this Gibbs energy of reaction is a function of temperature. This E is also a function of temperature. So you can just measure E at two different temperatures and then do delta E over delta T. And then use this equation to get the entropy of the reaction. For example, if you are interested in the entropy at, for example, the room temperature, you need to measure this E at 298.15 Kelvin and then maybe 298.16 Kelvin, 298.14 Kelvin, and then you make a graph, you plot this, you get the slope, you get delta E over delta T, and then multiply by NF, you get the entropy change of the reaction. So why this equation? It comes from this equation. You just replace delta E, delta G of R, the Gibbs energy of reaction, with negative NFE, and then you take out negative NF. You have this nice equation for the entropy of reaction. If you happen to measure this E, the cell potential, with all chemicals in the standard state, and then you will get the entropy of reaction in the standard state.